everyone. Today we are starting with application day 1 notes. So the top of your paper should look like this, but I'm going to scroll down to number 1. We're going to skip that warm up. Okay, so it says you were helping your mom shop for your hamster's half birthday. This is very important. So you want to buy her carrots and 1 running wheel. The cost per 1 carrot, I'm going to underline per here. That's usually a word that we want to look for. So cost per carrot is $1. The cost of running a running wheel is $11. Okay, so what is the slope? The slope is the number that's with that per, for every, for each, those types of words. So the cost per carrot is $1. So my slope is 1. All right, this one's different. You're thinking, okay, what's the y-intercept? So I'm going to write y equals mx plus b, my slope-intercept form here. So I just said, okay, my slope is 1. My y-intercept is that extra number that I'm adding in, and it's just a one-time charge. So they're just getting 1 running wheel. We don't need a lot of running wheels, just 1. So that is my y-intercept this time. So that is 11. Okay, then write an equation that models this in slope-intercept form. So I'm just plugging in my slope for m. So my slope is 1 times x. Remember, y and x are always in your equation, plus my y-intercept, which is 11. All right, not too bad. Let's scroll down here and then talk about this taxi. All right, so a taxi cab charges $5, a $5 ride fee, plus additional $3 per minute. Let's underline that per. So $3, that's my slope. My y-intercept is that one-time fee, so $5. So we'll write our equation then. We're going to plug into y equals mx plus b. So 3 times x and then plus my y-intercept, which is 5. It says, what's the cost for 20 minutes of ride time? So on the side here, I want to label my variables. I'm going to have x is equal to the number of minutes. Remember, you're looking for that per, and then your units typically right around that word. And then my y then would be the total charge for the taxi. So total charge, total money, something like that. Okay, so for 20 minutes, that's my x variable. I'm going to plug that in here for x. So y equals 3 times 20, and then plus 5. So what's 3 times 20? Good, 60, and then add 5. So we're going to have 65 here. And we need to label. So y equals 65. My unit for the y's is the total charge. That's money. So $65 for that cab ride. Yikes, that's expensive. Okay, turn over your page to the back side. Number 3 here. This is different than the first ones. It's just asking you for the meaning of these different variables. So you work as a mail deliverer. You have to deliver a certain amount of mail. The number of pieces left can be estimated with the equation f of x is equal to 1080 minus 120h. Okay, then it's telling us here f of x is equal to the number of pieces of mail left. So pieces of mail left. And h is the number of hours that you've worked. So this equation is saying, okay, this number here, that's the amount of mail that you're starting with. This is like your to-do list. I have 1,080 pieces of mail that need to be sorted. So that's what I'm going to write for the meaning of this number in the equation. So the number of pieces of mail that need to be sorted. And in parentheses, I'm going to write your starting value. That's what you're starting with. Okay, then this next part of the equation, it says minus 120 times h. H, we said, is number of hours. So this is something per hour. Since we are talking about sorting mail, delivering mail. The number in front of hours is the number of pieces of mail he delivers per hour. That's why they're being multiplied together. So this 120 is the number of pieces of mail delivered each hour. Okay, so I'm just going to show you what I mean here. 120 times H. H is number of hours. So say I worked for 2 hours. I would say, okay, that would be 240 pieces of mail that I delivered. The reason why it's a subtraction sign here is because you are taking away pieces of mail from your to-do list. This is your big to-do list. So subtract anything you get done, and eventually you want to get, to 0. That's why it's a minus. Okay, one more here, number 4. A plane loses altitude at the rate of 5 meters per second, begins with an altitude of 8,500. So begins, that's a keyword. Per, that's another good word. The plane's altitude is a function of the number of seconds that pass. Okay, so let's look at this part here then. So number of seconds, that has to be our x. And then if you see, they're telling us what the variables are actually right here. X is number of seconds passed, and y is the height of the airplane. And then I'm going to specify that the height in meters, because they give us that information. Okay, so my equation, I'm going to have y equals mx plus b format. So I have y equals, all right, my beginning altitude is $8,500. So that's what I'm going to start with here. This equation is going to be similar to the problem we looked at for number 3. So I'm actually going to write my b value first, and then my slope. So my slope, I'm falling. This airplane is starting, I don't know, say here, and it's going down, 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 because it's losing altitude. So since it's going down, I need a negative slope. So my slope, I have here in red, 5 meters per second. So it's minus 5 and then times x. So typically when your slope is negative, usually in these word problems, they'll write the b first, then the slope. Okay. If you wrote this though, if you wrote negative 5x plus 8,500, see how the negative sign still in front of the 5x, and there's a positive sign in front of the 8,500. Same thing here. That's okay then. That's the same thing. You just wrote this guy first. Okay, so then now we're going to use this equation that I just boxed to find how high off the ground is the plane after 60 seconds. So 60 seconds, that's my x. Okay, so plug that in for x here. So we have y equals 8,500 minus 5 times 60. Okay, so plug that into your calculator. What do you get? Good. You should get y is equal to 8,200. And then we'll label with meters. Very nice. Very nice. Okay, so that's how high this plane is off the ground after 60 seconds. Last part here. How long does it take for the plane to reach the ground? So if I'm thinking this line, this plane keeps going down, 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 down. When it reaches the ground, the height would be 0 then. So I'm going to plug in 0 for my y. And then I'm going to solve for x. All right, so what do I do first? Good, subtract the 8,500 from both sides. Okay, let me scroll up here a little bit. All right, so I have, this equation. Now what do? Good, divide by -5. Okay, so x is now equal to, these two negatives cancel to make a positive. So I'm going to divide 8,500 divided by 5. And you should get 1,700. And I'm going to label my x variable with seconds, which I labeled up here. Very nice. Okay. And that's all we're going to do today for the applications day 1 notes.